Hi students, today we're going to be looking at connecting exponential and logarithmic functions. The big idea here is that logs are just a way for us to write exponents so that we can work with them a little bit more easily. Alright, this is one of my favorite diagrams because this shows us that these letters can mean the same thing between exponentials and logs. We've got something that we call the base, which we are generally a lot more familiar with exponentials, because we talk about like 3 to the x would be base 3. Same thing for the log, that has a base as well. We call this a the argument. That's the math name for something that's on the inside of an expression. And I think about that as an argument here, or as the answer to the exponential problem. That might be a little bit easier to process. And then the last part is this e, and unsurprisingly, I hope, this means exponent in both cases. This gives us a format to convert back and forth between exponentials and logs. These two equations mean the same thing, they're just written in different ways. We often use this to evaluate things. So in terms of exponentials and logs, we try to figure out what value logs have. I'm going to start off by writing this as an e for exponent, because I have that thing that we talked about. So that's log base a, then we got exponent, and that connects to b to the e is equal to a. So if I rewrite this as an exponential expression, that would be my base 2 to my exponent e is equal to my argument 1. And I know that something to the power that equals 1 has to be 0. That first one would have an answer of 0. I'm going to look at the same thing on the next problem. We said that logs without a base are log base 10. We call it the common log. And the same thing is going on here. That's asking us to do 10 to the exponent is equal to 1. And again, that only works if we have 0 as our answer. Okay, next one, our base to our exponent is equal to our argument. 2 to some power is equal to 2. That power has to be 1. I'm going to do the same thing on the 10. Our base 10 to the exponent that we don't know yet is equal to the argument 10. Same thing. That's it. I feel like that's kind of a pattern here. Okay, so we've got 2 to the exponent is equal to 4. 2 squared is 4, so that's 2. We know this is base 10. 10 to some exponent is 100. We know 10 squared is 100, so this is going to be 2 as well. Then we've got 2 to some exponent is equal to 8. That exponent has to be 3 because 2 times 2 times 2 is 8. Same thing over here. 10 to some exponent is equal to 1,000. 10 times 10 times 10 is 1,000. That means that 3 would be the exponent there. Alright, so we're going to do the same thing to deal with this and try to figure out what's going on here. This lets us also remind ourselves what some weird exponential situations are. So for this one, I'm going to do this one in red. We've got 2 to the exponent is equal to 1. That exponent has to be 0. So that has a value of 0. For this one, we'd have 4 to the exponent is equal to 2. And that seems kind of weird to me. This seems like I shouldn't have an exponent then going down in value. Although you might remember that if we have something like 4 to the 1/2, that's the same as the square root of 4 by definition. And if we have the square root of 4, we know that's 2. So 4 to the 1/2 would give us 2 as an answer. So e is a half. And that means this value is a half. 1/2 is bigger than 0. Ooh, for this one we've got dealing with something that's going to be even weirder. So we've got 3 to some exponent is equal to 1/9. Okay, that seems kind of strange. This time I'm going to try a different approach. I'm going to try to make 1/9 look like 3. The first thing I'm going to do is to rewrite this as 9 to the negative 1, because we know that negative exponents flip things. They're reciprocals. The next thing I'm going to do is to rewrite the right side as 9 is the same as 3 squared. So we get something that works really well for us. 3 to the e is equal to 3 to the negative 2. Therefore, e is negative 2. All right, same thing for the other one. We've got 9 to the e is equal to 1/3. Oof. Cool. Let's see what we can do there. That's kind of blowing my mind to make that smaller again. So what if we said this was 3 squared to the e, and 1/3, I don't like that fraction, 3 to the negative 1. We have the bases the same now. What that means is that our powers have to be the same too. So 2e would have to be negative 1, and that tells us that that e is equal to negative 1/2. Given our two answers, negative 2 and negative 1/2, negative 1/2 is a bigger number. This is all about converting. Our goal is to get y by itself in each case, and in some cases we're going to have to do a couple steps to get there. Here we've got nothing with that y, so I can convert this to an exponential. Base 2 exponent x is equal to y, and we're done. For our second one, again, y is by itself, so we don't really have to do a heck of a lot. We've got base 4 exponent 2 is equal to y. For our third one, log y is not by itself yet, so I'm going to divide both sides by a and get log, I'm also going to write this as base 10, just to remind us, is equal to x over a. All right, base 10, so it's going to be 10 exponent x over a is equal to y. Ooh, this last one, I've got this stuff trapped inside the log, so I think I'm going to have to do some things first. I've got a base of 3 to the power of x is equal to 2y. To get y by itself, divide both sides by 2. So we have 3 to the x, divide by 2. At that point, this answer is done. We can also do the same thing working backwards. Our goal is to convert this to logarithmic form. So here I've got y is equal to x squared. Okay, I'm going to have log. My base is x. My answer is y. And my exponent is 2. Remember how I said logs are exponents? Logs will always equal an exponent. Going down to c, that's going to be log. My base is 1/3. My argument, my answer is y, and my exponent is x. For b, I'm going to get that x to the 4th by itself first, so that I have this exponential thing by itself. So then I've got log base x. Here's my argument of y over 10, and that equals my exponent of 4. The last piece is weird because I've got to rewrite this as x to the 1/2. If I don't write that as an exponent, I can't convert this to log, and that equals 3y. Cool, so I've got log base x of 3y is equal to my exponent of 1/2. And then finally, we got to do some evaluating stuff. I'm always going to set these equal to that exponent. So we've got 4 to some exponent is going to be 64. That value, 4 times 4 times 4, is going to be 64, so that'd be 3. For 2/3, 2/3 times itself some number of times is equal to 8 over 27. If you multiply 2 times 2 times 2, you get 8, and 3 times 3 times 3, you get 27. So that would be 3. Log of 100, we know that's base 10. So 10 to some exponent is 100. That exponent is 2. And then we've got the square root of 2 to some power is equal to 2. Well, I know if I square a square root, it goes away. So my exponent would be 2.